Hello GATE aspirants, welcome to part 13 of GATE Mathematical Physics series. Question number 13. What is the maximum number of free independent real parameters specifying an n-dimensional orthogonal matrix? So if we are considering orthogonal matrix, then A transpose is equal to identity matrix. Let us consider for 2 cross 2 matrix, and this matrix is A, B, C, D. So its transpose will be ACBD, and this is equal to identity matrix, that is 1 0 0 1. So this will be A square plus B square, AC plus BD, then AC plus BD, and C square plus D square, and this will be equal to 1 0 0 1. As you can see, these non-diagonal elements are same, and we will get conditions A square plus B square is equal to 1, C square plus D square is equal to 1, and AB plus CD is equal to 0. So this is what we are getting. So we have 3 constraints here. Now the number of elements is 4. So we can write it like this, 4, and these are 3 constraints. So that means the number of independent parameters, it will be 4 minus 3 is equal to 1. Now this 4 we can write this as n square, because it was 2 cross 2 matrix, minus this 3 can be written as n into n plus 1 by 1. So this will be equal to by 2, sorry. So this will be equal to 2n square minus n square minus n upon 2. So that is n square minus n by 2, that is n in bracket n minus 1 by 2. So this is basically number of elements in number of independent parameters in asymmetric tensor, that is an into n minus 1 upon 2. So here option C is correct. We have done this for 2 cross 2 matrix, and it is applicable for n cross n matrix as well. Next question. Consider the ordinary differential equation. Its solution is given. Then we have to find values of A, B and C. So we have y double dash minus 2xy dash plus 4y is equal to 0, and this is y. So let's find out y dash of x. So that will be b plus 2cx, and y double dash of x will be simply 2c. So let us substitute in this equation. So this will be 2c minus 2 into x into b plus 2cx plus 4 into a plus bx plus cx square is equal to 0. So that is 2c minus 2bx minus 4c into x square plus 4a plus 4bx plus 4cx square is equal to 0. So this will cancel out, and you will get 2c plus 4a, and 4b minus 2b is 2b. So plus 2bx is equal to 0. That means 2b is equal to 0 because there is no x term on the right hand side. That means b is equal to 0, and you get 2c plus 4a is equal to 0. So that means c is equal to minus of 2a. So c is equal to minus of 2a, which is not equal to 0, and b is equal to 0. So option B is correct. Next question. Complex function f of z is equal to z plus mod of z minus a square. A is a real number, is, and we have to check if it is continuous, differentiable or analytic. Now this is the function. F of z is equal to, z can be written as x plus iy, plus we have mod of z. This will be x plus iy minus a mod. So this is equal to x plus iy plus mod of this will be x, like we have to do this x minus a plus iy into x minus a minus iy, multiplication of it. So to find out its magnitude, we can do this x minus a square, and this will be I and y square, so minus iy square, and I square is minus 1, so this will be plus of y square. So this will be equal to, this we can write as x plus x minus a square plus y square plus I into y. So this is the real part, and this is the imaginary part. Now first we have to check whether it is continuous at AA. So first part, continuity at A. So for this purpose, left hand limit should be equal to right hand limit. So we will check. First we will consider parallel to x-axis. So here we will find out limit z tending to A f of z. Now this is equal to limit of x tending to A and f of z, and we will write here value of y to be equal to A. So this will be equal to limit x tending to A, and put y is equal to A in this equation. So this will be x plus x minus A square plus A square plus IA. So limit x tends to A, this will be A plus A minus A is 0 square plus A square plus IA. Now let us find out parallel to y-axis. This is parallel to x-axis. Let us find out parallel to y-axis. So here we will consider limit z tending to A f of z, and that will be equal to limit y tending to A and f of z, where we will write x is equal to A. X is equal to A. So this will be equal to limit y tending to A, and at place of x you will put A. So this will be, first it will be A plus, then A minus A is 0 plus y square, then plus IY. So this will be A plus A square plus IA. You can check along any other paths as well. So we are getting left hand limit, or these limits are same along any path. That means this function has to be continuous. So function is continuous at AA. So option A is correct. Next is complex differentiable at AA and complex differentiable at A0. So function will be complex differentiable if it is continuous. So let us check its continuity. We have this function f of z is equal to z plus, and this is x minus A plus IY mod square. Okay. So now if x is equal to A and if y is equal to 0, then in that case f of z is equal to z. Now z function, it is continuous, so it will be differentiable. So option C is correct. Next, if x is equal to A and y is equal to A, if x is equal to A and y is equal to A, then we will get f of z to be equal to z plus x is A, so this will be 0, and I A square. So this will be x plus IY plus IY square, so that is mod of it. So here, since there is mod function, modulus function is there, and this modulus function is not continuous, so we can say that it is not differentiable. So option B is wrong. And next is analytic at A0. So function is analytic, that means that function is continuous. Also it should be differentiable everywhere within that region. That we are not getting here. So only option A and C are correct in this question. Next, if g of k is the Fourier transform of f of x, then which of the following are true? Now g of k is equal to, we have 1 upon root 2 pi integration minus infinity to infinity f of x e raised to minus ikx dx. That is Fourier transform of f of x. Now let us find out g star of x, its complex conjugate. It will be 1 upon root 2 pi, then minus infinity to infinity, complex conjugate of f of x, and here it will be minus I plus I. So ikx dx. Also let us find out g of minus k. This is k here. Also find out g of minus k. So it will be 1 upon root 2 pi, then minus infinity to infinity. In this first equation, replace k by minus k. So this will be f of x into e raised to minus kx. This will be ikx dx. So we can see that left hand side, these two will be same if f of x will be equal to f star of x. So we can say g of k is equal to g star of k if f of x is equal to f star of x. That means f of x is real, and g of minus k will be equal to minus of g star of k if f of x is equal to minus of f star of x, and that means f of x is purely imaginary. So if function is real, then its complex conjugate is same, and if it is purely imaginary, then just that I will change sign, so it will be minus of that thing. So here option A is correct and option B is correct. Next question. The ordinary differential equation has regular singularity at. So first of all, let us find out its singularities. We can write y double dash, we can throughout divide by 1 minus x square. So this will be minus of x upon 1 minus x square into y dash plus 9 upon 1 minus x square is equal to into y is equal to 0. So here p of x is equal to minus of x upon 1 minus x square, and q of x is equal to 9 upon 1 minus x square. So both of them will have same singular point, that is 1 minus x square is equal to 0. So 1 is equal to x square. So x is equal to plus or minus 1. So let us check. At x is equal to plus 1. So this will be x minus 1 into p of x. We are trying to find out their singularities or their residue points. So this will be x minus 1 into p of x is minus of x upon, so this is 1 minus x square, I can take this minus sign in the denominator, so this will be x square minus 1. So this will be x minus 1 into x plus 1. So this will cancel out, and at point x is equal to 1 we are checking, so this will be 1 upon 2. Then at the same point we can check for q as well, so this will be x minus 1 into q of x. So x minus 1 into 9 upon 1 minus x, 1 plus x. So there is one minus sign here, so we'll have minus sign 9 upon x plus 1, that is 2. Then at x is equal to minus of 1, x minus 1 into p of x, x plus 1 will be there now. So this will be x plus 1 upon x, x upon x minus 1, x plus 1. So this will cancel out, and x is minus of 1. So minus 1 upon minus 1 minus 1. So that is minus 2. So minus 1 upon minus 2, that is 1 by 2. Then x plus 1 into q of x. So that is x plus 1, 9 upon 1 minus x, 1 plus x. So this will cancel out, and 1 minus minus 1 is 2. So this will be 9 by 2. So at in each case we are getting some finite value, and this is finite value, that means the singularities are regular singularities. So here option A and C are correct. So these were all the questions from GATE 2022 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.